10.1 talks about infinite series. So what a series is, it's the sum of a set amount of terms. Some are finite, some are infinite. We're interested in the infinite, of course. But the finite, you start at 1 and you sum. So you throw 1 in there, then you throw 2 in there, then 3 all the way until you throw n, you terminate. That's if it's finite. S sub n indicates that this stops at the nth term. Now, S sub infinity would be the sum from I equal 1 to infinity, very close to the top, except you start with 1, you put 2, and you run all the way to infinity. So, infinite series, we have one specific that we really care about, and it's called the geometric series. And geometric series are very important. They really play a big role in what we come across. If you ever recognize that it is a geometric series, and this is what a geometric series look like. You look at a term. To get the next term, you take the first term and multiply it by r. To get the next term, you multiply by r. So each term is found by multiplying the previous term by r. And to find r, you take any term that you want and you divide it by the previous term, so going backwards. If you happen to know that you have a geometric series for sure, then if the absolute value of this r is less than 1, meaning if r is between -1 and 1, not included, then the infinite sum, the sum from 1 to infinity of all of these terms, will be the first term on the sequence. Now you got to be careful with that. The first term on the sequence is not always a sub 1. The first term, it's whatever you plug in to get the first on the list, divided by 1 minus r. So I'm going to elaborate on that as I do examples. Example 1, given the following geometric setup, telling you this is geometric. Find the sum. In this case, when you replace n by 1, you notice the first term on the list is a 1. To find r, you take any term and you divide it by the previous term. Or you simply glance at it and say, okay, what do I multiply this with to get that? Well, the top is the same. The top is fixed. It's the denominator that's being multiplied by 2. Well, if I multiply this by 1 over 2, would I get that? And that does work. So this infinite series, either you write S or S sub infinity, whatever you like, is the very first term on the list divided by 1 minus r. What's the first term on the list? In this case, it's 1/2. Divided by 1 minus r. Clear the fractions. LCD is 2. And this would be a 1. If you add a half plus a fourth plus an eighth all the way up, you will take a 1. Now, if you get your calculator and add the first 20 terms, you'll get 0.99999. The only way you would reach infinity, the only way you would reach 1, if you kept on adding all the way to infinity. That's the catch. But if you were able to reach that, you will get a 1. Notice the next part, or the next example, looks very much like the first example. R is still 1/2. But now the infinite sum, A sub infinity, or S sub infinity, is the very first term divided by 1 minus r. Here, do you notice that you're starting at 0? So if you put 0 and 1 over 2 to the 0 is 1. Divided by 1 minus r. And if you clear the fractions, here the sum will be 2. If you were able to add those infinite terms, you will get 2. If you add the first 20 terms, you'll notice you'll get 1.9999. You will never get to 2 unless you run all the way to infinity. This is a geometric series. Again, what you want to find R. R is, what do you multiply this with to get the same thing squared? Well, obviously 2 over 5. That is less than 1 in absolute value. So this infinite sum is going to equal the very first term divided by 1 minus R. The first term on the list is 2/5 divided by 1 minus 2/5. The LCD is a 5. So multiply this by 5 top and bottom. That will be 2 over 5 minus 2. That will be 2/3. 0.6666 all the way down to infinity. So this is a repeated decimal. Part D. R equals, what do you multiply 1 with to get 3/4? 3/4. That is less than 1. So this infinite sum would be the very first term, in this case it's a 1, divided by 1 minus 3/4. LCD is a 4. 4 minus 3. That infinite sum is really 4. Again, I can get as close to 4 as I like, 3.99, but I can never reach there. If I was able to reach infinity, I'll get the 4. We have alternating series that multiply by a negative, meaning, what do you multiply 1 with to get negative? Oh, I messed up on that one. Let me fix it. Sorry about that. So what do you multiply 1 with to get negative 1 over 7? We say R is negative 1 over 7. And if you multiply negative 1 over 7 by negative 1 over 7, you get a positive 1 over 7 squared. In absolute value, that is 1 over 7, which is less than 1. So this infinite sum will equal the very first term divided by 1 minus, and R is a negative 1 over 7. So that is 1 over 1 plus 1 over 7. LCD is a 7. 7/8 is the infinite sum. And they could not give us the formula. They could just give us the list of numbers. Here's the list. You start with 5, then negative 1, then 1/5. Well, what do you multiply 5 with to get negative 1? That's a bit hard to see. Well, R equal, take any term divided by the previous term. R is really negative 1/5. If I multiply 1 over 5 by negative 1 over 5, I will get negative 1 over 25. In absolute value, that is less than 1. So this infinite sum would be the very first term, which is a 5, divided by 1 minus 1/5. The LCD is a 5. 25 over 5 minus 1. That's really 25 over 4. And this is a very short section. And that's pretty much it for this section. Okay, it seems I made a mistake right here. That should be R is negative 1/5. So you end up adding, not subtracting, so the denominator is actually a 6. And that takes care of it. I wanted to leave a note. If the absolute value of R is bigger than 1, meaning if R is less than negative 1 or R is bigger than 1. So on a number line, if R is in either of those two places, then the series of A sub n will diverge if it is geometric. Just keep that in mind. The book doesn't talk about that now, but something to keep in mind.